how do you create that moat around your company or around your technology so that there's not 1,000 of you? Because if there are 1,000 of you, you're never going to be able to continue to scale. You're just going to be a small company forever. And so a lot of it comes back to understanding having both of those components of your business plan, or at least of the idea that you're going about, is how am I going to defend this? How am I going to make my value proposition something that others can't replicate?
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Brian Peters, founder and CEO at Inneos. Brian, thanks for chatting with me today.
David, pleasure to be here. Happy to be here.
No, this is exciting. I think this is you bring an important capability. So let's learn more about it. But before we get there, tell me a little bit about your journey. What had you, think of this, and how did you get to this point?
So I started off my career in engineering background, right? Mechanical engineering, materials engineering. I actually started off in aerospace company designing, manufacturing what were known as klystron tubes. Back in the day, the core of a radar system. And I kind of cut my teeth in that area. Certainly an interesting company because we did both design and manufacturing. And that's kind of where I got my desire to integrate both. I saw value in having manufacturing right next to engineering. So after that, I actually got recruited over to a laser company to kind of do the same thing that I was doing at this aerospace and defense company. Had no idea about lasers, but they were these big behemoths of a box about the length of a baseball bat, and obviously nowadays we're talking about much smaller. But at the time, it was something that people assembled together, and a lot of engineering, a lot of craftsmanship. And so it was a really interesting transition for me because I was getting out of aerospace and defense, where there was kind of a known purpose, and into lasers. And this is back in the 90s, early 90s. And our president kept walking around the company saying, lasers are a solution looking for a problem. It's kind of the inverse. I mean, here we are today where lasers are pretty commonplace. But back then it was like, we don't even know what we're going to do with this thing. And we can sell it in various places. But it kind of opened my eyes and made me fairly intrigued with the concept of lasers, laser light, and what you could do with it. So I actually went back, got an MBA with the purpose of eventually starting my own company. Did that right out of MBA, started a small company doing read-write technology for DVD drives, things like that. Actually sold the technology to a big DVD manufacturer. They integrated it. Don't see DVDs anymore, but some of the stuff we were doing was part of that. And right after that, I actually started what was the original version of this company. By that, I mean, I started a company that was doing almost the same technology, same idea, but we were going after datacom. And after doing that for several years, we were acquired by a big Japanese company that came in, bought us out. Very cool, smaller company at the time. We were a smaller company at the time. It was good to be part of a bigger team. And so they bought it, took it over, integrated it into themselves. And after a while, they realized that photonics was not their comfortable space, right? It's not their happy space. And so they decided they wanted to sell it. And, me being an engineer, of course, I said, well, what better thing to do than just buy your own company back, right? So that's awesome. So I bought it back. And in part because I saw the landscape changing. And again, this is back in 2010, 11-ish. And I saw the landscape changing, and I thought there were some new areas that we could be pursuing. So bought it back, reconfigured it into what is now Inneos, and kind of put me in the place that I am today.
What does Inneos stand for? Or is there a name? Like, how'd you come up with that name?
Inneos is a combination of innovation, and Eos, we treat it as the goddess of light. Really, Eos is the goddess of dawn, but close enough, right? As the sun comes up. So it's a combination of
that's cool.
Words.
That's awesome. Well, for those that don't know, we've talked about it a little bit, but what is Inneos? What's the vision for Inneos? What do you guys do?
Yeah. So we're not necessarily the sexiest company in the sense that we build the end product that everybody sees. We are more of an infrastructure. We're what we call a subsystem. We design and manufacture all of our own devices that effectively go inside systems. Our primary purpose, I try and communicate this in a way to our customers, to everybody I talk to. We're almost like a truck or a train. Our purpose is to take the data from one point to another. But what we do that with fiber optics, right? We don't do that with the traditional copper wire. We don't do that with electronics. We do it with lasers, light, and fiber optics. So our role is really creating a link. Usually it's a high performance link between two systems or even within a system. And interestingly, as AI and other massive chips have evolved, we're finding that link now is as short as between chips. And so a lot of people think about fiber optics as this telecom thing, and it's really about moving video or data across the country or across the ocean. Now we're talking about just moving data a few millimeters, and that's all being done in fiber. And that's really what our role is, right? We design and manufacture the devices that allow our customers, our partners, the OEMs really, to create that signal and then put that signal onto our carrier and then move it to the other side. That's the simplest way I can describe our role in this.
Well, that's cool. And I know, if you look at their website, they've got F-15s, which I'm a big fan of. But there are, what is the advantage of, using fiber optics and what was used before?
Let me do this for a second. I'm just going to level set or just kind of get everybody thinking along the same terms that I do or we do. So first of all, I want to somewhat define the term fiber optics because it's really become an easier and a simpler word for what is really known as photonics. And by that, I mean, fiber optics is really about a cable. And it's a cable made of glass, and we communicate with it. But the reality is everyone uses fiber optics as any form of communication where you've got laser, light, et cetera. And so when we talk about it, we use the geeky word photonics, but in reality, most people talk about it fiber optics. It's all the same. And again, it's distances as short as a few millimeters. And so what we've been doing that is interesting and kind of separates us from everybody else is that when you look at copper wire, when you look at electronics, there are a number of deficiencies, especially as we've gotten in higher speeds with the wire, with the electronics, right? Copper wire is very heavy. High-speed electronics are very power hungry. Right? We hear it all the time. We hear about data centers and the massive amount of electricity they consume. Same thing goes in EVs, right? Electronic vehicles that we're talking about. Huge battery hogs when you talk about all the electronics that are in there. Wires, you can tap into them, which presents a security problem. So if you look at that kind of that big bubble of what we have been using for the longest time, copper wires, electronics, there are certainly, and I would never argue that those need to be replaced. They have a huge benefit, but they also have deficiencies. And so what we're trying to do and what we've been seeing of late is the industry, and especially the DIB industry, but even commercial avionics is doing the same thing. We all recognize those deficiencies and what they cost, right? And cost, I mean, both in terms of real financial costs, right? So when you're talking about weight, you're talking about fuel, and fuel costs money. You're also talking about signals that are interfering with each other and other things. So we've been working on coming up with products that fit into that space that can effectively replace all of the copper wire and all of the endpoints of those copper wires with fiber optics. And then, as I said, like you talk about F-15s, you're talking about fighter jets, talking about commercial aircraft, but we're not limited and certainly not even focusing on just aircraft. It's applicable to mobile craft on the ground. We're talking about ships on the ocean, right? Weight. All of those things still have the same factor. And we kind of use this term we call swappy. If you've ever seen the movie WALL-E, right? The little robot that's cruising around, it's the same thing. It's just an acronym, right? It's still kind of a fun acronym, but it stands for size, weight, power, and EMI. And those are the key characteristics that we've been focusing on to displace. As I said, bandwidth is certainly a factor, but far more important to a lot of vehicles today are in fact the weight and are in fact the EMI that comes out of those that lends those vehicles to be susceptible to tapping into wirelessly or even physically tapping into the wire itself. So a lot of what we've been doing the last couple of years are trying to find ways and building products that would effectively allow our partners, those in the defense industry, to rip out some copper wires and put in fiber optics instead.
That's great. And are you finding that the demand signal is higher for new, like new acquisition programs, new, platforms, or is there a big demand? I picture, F-15, for example, and I mentioned this earlier, lots of copper wires. I ended up having to eject out of one because there was miles, I think, of copper wire in this F-15 as they kept rerouting things. And that's just a lot of, chance for things to happen, and ended up having a short that messed up my fuel or turned off all fuel to all engines. But are you seeing a demand for replacing? Because I imagine that's pretty expensive in some respects, but also could be both weight and, reducing things like that could happen. Where do you see that demand signal mostly right now?
Yeah, we have been seeing most of it in new. Most of it has been in new design projects, new aircraft. But one of the interesting components or elements about this industry is there's a lot of reference that goes on. And, people, companies, they reference each other's projects because no matter what, we're still talking about lives that are at stake. We're talking about expensive equipment that's at stake. Nobody wants to make a mistake. So you really want to have some level of proof of concept before you go adopting something. Now, the newer vehicles have the funding and the capacity to experiment with these things and get them figured out. And that's where most of our work has been. That has lent itself to a lot more retrofit because now the programs that have been in existence for a while can look at the new program and say, well, wait a minute. Okay, great. You've already proven the fact that, Inneos's devices can handle the shock and vibe that we've been talking about. We've already figured out how to deal with the massive temperature profiles when these things are up in the engine compartments, right? Those are all fear factors that any engineer is going to have in adopting a new technology. And the fact that we're able to already prove it out in a platform over here, we can then leverage that and take it into a platform over here. So now we're actually seeing that some of the interesting inquiries have come along to consider not necessarily weight reduction, although that's a secondary factor, but really to reduce the repair time. Because all of the work that has, like you just said, when you have this rat's nest of wire in there, the repair time for a plane or a vehicle that is down is weeks or months because they're trying to figure out if anyone has ever tried to diagnose their car when an electronic problem has occurred, you don't know where to look. Right, you're going through all the different connections and trying to jiggle things to see if something lights up, and it's very similar. And so a lot of what we're seeing is for repairs and upgrades as new phases come along, they are actually going in and pulling out copper wire and replacing with fiber optics because one tiny little 200 micron strand of fiber can replace a big old bundle of wire. And so yes, the cost is not trivial, but the long-term cost of that repair and that upgrade far more than pays off itself.
Oh yeah, just I can imagine the weight savings too.
And the weight savings, you're absolutely right. I mean, the weight savings. Don't know if you've ever looked at the numbers, but like even this is somewhat in your world, right? Cat 5 cabling or Cat 6 cabling, right? Those things are very commonplace. You're talking about 45 pounds for every 1,000 feet. Give that to a comparison of a fiber. Fiber is about 3 pounds for 1,000 feet. Now you talk about, I think I read the 747 has 700,000 feet of wire. And you're talking about 15 tons of wire in that aircraft. You could take that down. I'm not just talking about by a fraction. I'm talking about you take that down an order of magnitude, right? You take it from 15 tons down to maybe a ton, and without obviously any loss of performance. The fiber has far more upside on the performance side. So no doubt you're absolutely right. The weight savings is a huge factor.
Yeah, that's very cool. So obviously, space and aerospace makes sense, right? Because weight, swappy makes sense. Where are you seeing this in other, let's call it platforms? That there's a demand signal of, ooh, this also has a unique, value proposition to customers.
Yeah, we are. I think it goes more towards the world of autonomy, and I think as we've seen the last couple of years with AI. I think it sent a signal, not to play on your words at all, but sent a signal to a lot of us that unmanned vehicles, autonomous vehicles are coming. It's not a matter of if, it's a when. And that is absolutely true in the military. And like you just said, I am not just talking aircraft. I think we are seeing ground vehicles that will be unmanned. We are seeing boats that will be unmanned. And a lot of these have a different purpose. You're obviously not going to send an aircraft carrier out unmanned, but there are certain purposes and certain reasons for having these. And a lot of it comes back to keeping our troops safe. There's no need to put some of them in harm's way if you don't have to. There's certainly a lot of reasons that we still need troops. So I'm not talking about displacing troops, but I am talking about a lot of applications where UGVs and USVs, they're going to go autonomous. And in order for them to be autonomous, they face the same challenges that we do on the commercial side. And that is, you have a battery, and a battery has finite life. And so if you can maximize the range of that vehicle, if you can maximize the amount of intelligence or the CPU power that you have in there, instead of wasting it on transmission. And so where we're seeing some pickup is actually on the UGV side, where they're trying to look at how do we make these vehicles a lot more autonomous, or I would say in this case, it's really semi-autonomous. We're putting more intelligence. The computer can do a lot more decision making than we can, and faster than we can. There are a lot of things, especially with reasoning, that we can't, and that a computer, can help us. So, there's a balance between the two. So I call it semi-autonomous, because I'm not talking about full autonomous vehicles. But in that case, with a lot of these military vehicles, semi-autonomous vehicles, they're trying to replace the copper infrastructure with a fiber infrastructure so that you regain the weight, and at the same time you maintain a lot of security. So we're seeing it in, like you said, aircraft, spacecrafts, ships, ground vehicles, you name it.
Let's pull a thread on the security piece. I'm sure this is EMI. Talk to me about what customers are saying and why this is really better.
Two levels of threat at the copper side. Number one is the one we've been talking about, which is EMI, and the fact that when you're talking about electronics, no matter what, there is going to be a radiation emission coming off of those. And it's fairly easy to tap into that emission. And you can do that, obviously, it's all wirelessly, and you can do it at a distance. Now, that distance really depends on the power signal that's going on. So it's not like I can be miles away from, say, a ground-based vehicle that's got a weapon system, armed. You would have to be fairly close, but nonetheless, you can do it. Command and control centers, great point, where you don't have to be very far away and you can tap into the EMI. But more importantly, on something like a command and control center, which again, you're talking about these tents that pop up and they need to be mobile. And so, we are seeing a lot of applications for our stuff in that space because it's easy to install and get up and running. But now you've buried this copper wire in the ground. Any amateur can go in and scrape a copper wire and tap into it, right? It's just a matter of splicing. Now, certainly there's protocols and there's securities that make it more challenging, but physically it's fairly easy to do. And with a little bit of technology, it's actually easy enough to do by just wrapping around it and tapping into it. So you can tap into a copper wire fairly easily. You cannot do the same with a fiber optic, right? A fiber optic cable and the way light propagates and the way it works, if you disrupt that in any way, if you change the physics of that cable, or really in this case, it's a waveguide, you will know it. You will know it and you can detect it. And so the physical security of a fiber cable is a lot greater than it is for a copper wire.
That's very cool. Definitely a threat out there, that's for sure.
It's definitely a threat, and it's one that's often overlooked. And the funny thing is, what we're talking about here is a DIB space, but we are seeing it a big component of our businesses in the medical space, and they have become equally concerned about hacking for all the same reasons. And so that infrastructure is identical. Copper wires everywhere, and they're replacing it with fiber optics. So you have two, one of the things that we try and focus on as a company is because of what we do, we stay in the area that's mission critical, right? We're not commodity. We don't do the stuff that's easy peasy, right? We're doing the things that are mission critical, where lives matter or equipment matters. And DIB and medical are identical in that sense, and they happen to be identical, at least of recent, in their concerns for security.
Are you finding like data centers? Like I would think that would be massive, or are they already kind of doing their own?
Yeah. So a data center short answer is we stay away from there for a variety of reasons. First of all, a data center is driven first and foremost by profitability. And so while I will never go so far as to say they don't care about security, their level of security is far less than anything that you and I deal with in the DIB space. So they think first and foremost about the cheapest. And second of all, you look at the operating environment for a data center, you're talking about nice air conditioned or reasonably air conditioned space. A lot of companies, we're in the fiber optic space, but we're not the only company in the fiber optic space, right? There's a lot of companies like us in this space. But most people are designing and really have the capability for products that need to fit into a controlled environment. That's not us. We're actually the opposite. We have some of our technology allows us to put our devices right next to the hottest part of an engine. Now you're talking about 100, 120 degrees Celsius. Most optical devices can't survive more than 80 degrees. So, and the same goes to the flip side, right? We can go down to minus 50 where it's freezing up in the Arctic, and you can't take a data center device. So for two reasons, right? We play in that space because others can't. Conversely, we don't really look at the datacom space or the data center space as for us because the value proposition we bring isn't of interest to them. They're really just worried about bandwidth, and they're just worried about cost.
Well, folks that are looking to, other companies in your space, what unique things have you brought to this that really enable you to, be a leader?
Yeah. I mean, it's a great question. We've carved ourselves a nice little space because of a technology. Actually, I'm going to date myself back to the 90s when we first started, because we actually developed the core of the technology back then. What makes us different and where we play the best is in the idea that while I've already articulated a number of benefits for fiber optic itself. As you expand, as you talk about greater bandwidth or a number of different signals, let's take this to the UAVs again. Sensors exist at the edge of the vehicles, and all of that data has to come back to the CPU, and those are all separate signals. One would look at that and say, well, I'm just going to run a fiber to every one of those. Well, again, now you're talking about adding more weight. That doesn't necessarily have to happen. What we developed a long time ago, and we continue to be at the forefront of, is the idea of putting multiple signals onto a single strand of fiber. I'm not going to talk about one cable, right? A cable can have many strands. A fiber optic cable can be comprised of 5, 10, 30 strands of fiber. I'm talking about on one single strand of fiber, we can actually put 3, 5, 10, 15, 16 different signals. And we do that because we're using different wavelengths, right? So think about it as a rainbow. We're firing a rainbow into a fiber, and that rainbow, every single color on that rainbow is its own discrete channel. The beauty of it, like we were talking about earlier, light waves do not emit EMI. So therefore, now I don't get any noise coming between my two channels. And so we can send these signals down this backbone. So we're increasing the capacity of the fiber. More importantly, as I think about autonomous vehicles, one of the analogies I draw is it's not too dissimilar to the human body. What we've been focusing on with autonomous vehicles is the autonomy part, right? That's the brain. That how do we make decisions? But the reality of the human body, just like you and I are sitting here talking, is the fact that we sense things, whether it's by touch, whether it's by smell, by feel, and all of those sensors are then transmitting signals back to our brain through our nervous system and our spinal cord. What we do is kind of like the spinal cord, right? If you imagine all of these sensors at the edge of a vehicle, all of them are coming back to the CPU some way. Well, instead of having 20 different strands of fiber coming back to the CPU, we do all of that on one strand of fiber. So we've got these touch points that reach out. They come back, we can combine all of that onto a single fiber, transmit it to the CPU, undo it at the other end into the 8 or 10 different signals. And so it's no different than if you had 10 or 20 connected, but the reality is you're doing it with one strand. So we've been able to kind of carve out our space. And as I talk about it, it's our moat, right? We built ourselves a moat that makes us unique. There's only a few companies in the world that can do what we do. And the reality is most of them use more of the brute force method of saying, I'm just going to take one laser, one signal, and one fiber, and I'm going to transmit it to the other side. And if you want two, well, that's two lasers, two fibers, boom, you're done. And if you want 10, right, you see how it scales. And that's what we do differently. We do not do it that way. We combine all of that onto a single fiber.
That's great. What a great analogy, too. That I can understand. That's cool. Talk to me a little bit about now the business side. How did you get yourself going with funding, and have you had to take capital? Like, what does that look like? As well as in the government space, have you gone to any like SIBR or SITR contracts, things like that?
So going all the way back to when I first started, as I said, the original version of this company, that was a full VC funded company. And this was back, as I said, in 1998, 99. And for those of the audience that are too young to either remember this or even know this, there was an optical bubble, right? The dot-com bubble happened in 2000, and everything that was internet became hot. But what a lot of people don't realize is really almost adjacent to, but just slightly behind or slightly delayed, was the optical bubble. It was for the same reason, because we all saw what was happening with internet. Internet meant bandwidth, bandwidth meant fiber optics. There were fiber optic companies left and right that were raising money all over the place. So this was in 1999, 2000, 2001 timeframe. And so when we started, I really didn't know that. And so we started off, first round of funding I did was friends and family. Second round was a small group of friends that were a little bit more professional investors. And then by the time we actually got to some serious money, we ended up doing 3 rounds of VC money. And that was because that was the thing. Now, as it turns out, dot-com bubble burst, and so did the photonics bubble. So everything kind of changed. But for us, we were fairly well funded by that point, and we were off and running, and we weren't profitable, but we had enough in the bank, and we kind of got ourselves through, and then ended up getting, as I said, we got acquired. Now, fast forward to when I bought it back. Completely different story, right? Photonics or fiber optics, not the hot thing anymore. Funding not available. I did that all bootstrap. I just basically went to the company. I said, I want to buy this back. I don't have all the cash right now, but I'm going to pull it together. And effectively, I did it via debt. By that, I mean, it was seller funded debt. They agreed to sell it to me. It would be paid back over time. And I was adamant that we were going to pay it back. And we did. I basically, over a couple of years, paid all the money that I owed them and got the company up and running all by itself. Since that time, and I will not joke about this, within 6 months of buying it back, this is a company that when I sold it to them, we weren't profitable. We turned profitable. By the time I bought it back, it was not profitable. Within 6 months, it was profitable. And we have not been not profitable ever since then. And a lot of that is really about the discipline side, right? We've been focused on making sure it's what I call spending behind revenues. A lot of people spend ahead of revenues, right? And there's no doubt you have to make investments at time in order for those revenues to come, but there's different ways of doing it. And when I say spend behind the revenues, I mean, I know the revenues are coming in. That could be a future date, but it means that I've got either orders booked or I've got contracts or I've got something. And so we've done most of this in the last 8 to 10 years, all bootstrap, because we've maintained a discipline. We've kept ourselves in line with our revenues, even though our revenues have fluctuated like everybody else. I even have managed to, buy another company in the process. Bought a second company back in 16. I'll tangent for a second to explain why. I talked earlier about what makes us unique in our technology, but what also makes us unique is that I have been a believer since the beginning that manufacturing and engineering belong together. And we have had our own manufacturing facility since day one, right here in California. A philosophy I've maintained is anything that's critical, we need to be able to do ourselves. We need to control it ourselves. One thing that became apparent was lasers were not in our control anymore. And it almost cost the company a couple times. And I said, enough of that. So I actually went and bought a laser company. And so now we have our own semiconductor fab facility up in Nevada where we build our own lasers. So I needed to do that to control our supply chain, to really control some critical parts about who we are. And I'm never going to say that you should build everything in-house, but I do believe, and especially in today's world of onshoring, et cetera, that you need to have a capability that you can defend. And some of those things are embedded in the manufacturing side. So went out and bought that company, integrated it, and it's actually been great. And it's opened up a number of opportunities. Relating back to your question, we didn't go looking for this, but we have been pulled into a number of government contracts to develop some very high speed, but very high temperature lasers. For all of the applications that we're talking about, right? And actually, we're even to the extent we're talking about space flight, right? So now the DIB programs are really starting to push the edge because we're talking about extreme temperatures, and that's what our facility up in Nevada gets us the ability to do. We design it, but more importantly, we can manufacture it, so we can control the processes, and we can figure out the processes that we have in order to make those lasers survive these extreme temperatures. So not a big part of our business, these contracts, but it's a fun part, and it really, it allows us to push the boundaries a little bit.
What a great story. Own company, buy it back, and with that, clear it up.
That's what everyone thinks about, right? Go buy a company you just sold, right?
Some of the funniest stories or the greatest stories where that's happened multiple times, and it's just it's, I guess, especially with like private equity, it's tough for them to necessarily sometimes run those, or big conglomerates, because it's not their expertise. You take the founder out, and it's tough.
Oftentimes, and I'm not one who believes that any individual is irreplaceable, but there's difference between being irreplaceable and having nuances and the embedded knowledge that goes with. And so anyone can figure these things out. It's really a matter of time. And so a lot of times I do a lot of mentoring for some of the universities around here with startups. And I see a lot of these startups where these founders, all that is in their head. And while it's easy to replace them, you can't replace what's in their head. And that's really what I found with our situation is I'm no expert. I'm not great at anything. I just had a lot of stuff in my head, and I knew the nuances of our industry, and I knew the particulars of where things would succeed and where they wouldn't. And so that's what's allowed us to survive.
What is your, you mentioned it, you mentor, but, for folks that want to, defense innovators and break into the defense sector, what would be some advice you would share?
I would actually share the same advice in a convoluted way that I do with a lot of these startups coming out of universities. Let me expand on that a little bit. What I find interesting about the DIB industry is that it's what I call a high floor, low ceiling industry. By that, I mean, most of the partners we've come across are very reasonable in their expectations of their suppliers, whether that's development or just supplying product off the shelf. They're willing to pay a fair price, not an insane price, but a fair price. They're not going to let anyone go out of business. Even the government is willing to pay a fair rate for people to go in and take risk and develop some of these new things. Now, that allows for a high floor, meaning you can probably have a decent revenue coming in order to sustain your business. On the flip side, it's got a low ceiling because there's no real differentiation between two companies. You can have hundreds of companies all trying to do the same technology. You can have hundreds of companies all trying to do the same thing. So one of the things that I talk about to the students I mentor, and what I would advise anyone trying to get into this space, knowing that you've got this kind of an industry where I don't want to call it that companies are commoditized, but differentiation is not huge, that you need to have as strong of a defensive plan as you do it as an offensive plan. And by that, I mean, a lot of people go in and they think, what am I going to do that's going to make our customers want to buy our product or our service? That's your offensive plan, right? That's your offering. But how do you defend that? How do you create that moat around your company or around your technology so that there's not 1,000 of you? Because if there are 1,000 of you, you're never going to be able to continue to scale. You're just going to be a small company forever. And so a lot of it comes back to understanding having both of those components of your business plan, or at least of the idea that you're going about, is how am I going to defend this? How am I going to make my value proposition something that others can't replicate? And if you can get into the D&D space with that, that allows you to scale a lot faster, because now your value proposition, now the reason for people talking to you isn't because you're just one of 1,000. It's because you created something unique that you, or maybe only you and another, can do. And as that gets integrated into hardware or into software or into part of the procedures, then you are integral and you grow your company that way.
Great advice. I think a lot more challenging than you just made it sound. Yeah,
it absolutely is. When I talk to these students, a lot of times, they'll do their pitch, and pitches are always based on your offensive plan. And normally a pitch will take 5-10 minutes. And after 5 or 10 minutes of conversation, I'll ask them about the defensive side. And we will spend 2 hours on the defensive side because nobody really understands it. It's a hard question to answer. And the offensive side is easy. The defensive side is hard. So yeah, I agree with you. I'm not trying to make it sound simple. It does sound simple, but it's a very hard question to answer for most people.
Absolutely. Well, Brian, it's been awesome. Unfortunately, we're going to have to wrap it up for today, but what a great perspective. Love what you guys are doing for our country, our warfighters, our technology capability. If someone wants to follow what you guys are doing and just plug in and see an amazing company that's just doing, down in the trenches, making stuff happen, how would they do that?
Obviously, Inneos.com, easy way to see us. We have a pretty good presence on LinkedIn as well. We do a lot of social media on there just to keep people aware. A little bit of Facebook, but I think social media is a better platform. Our best customers are the engineers. And they do spend more time on LinkedIn and not necessarily on Facebook. So I would tell everyone go to LinkedIn, follow us there, and take a look at what we're doing.
Awesome. Well, thank you, Brian. Amazing. Look forward to great progress and getting Inneos in the news. And it's been fun. Learned a lot.
I appreciate it. I loved having the conversation. Great to talk with you.
All right. Thank you, sir. Take care.
All right. You too. See ya.